So you spent hours, maybe even days, getting the design for your next 3D print just right. It's perfect, it's ready to go. But wait, what are you actually going to make it out of? That right there is the secret ingredient we're talking about today, the polymer. We're going to see why the material you choose is every bit as important as the design itself.
Okay, so let's start with the basics. The star of the show here is the polymer. You can think of it as the ink for your 3D printer. These are just materials, like plastics or resins that can be melted down and then shaped into anything you can dream up. They are the literal building blocks that turn that file on your computer into a thing you can hold in your hand.
All right, your amazing design is locked in. You go to hit print and whoa, suddenly you're staring at a huge list of options. PLA, ABS, PETG, what does it all mean? This is the big question, right? Which material do you choose? If you get it right, you've got a perfect functional part. But if you get it wrong, well, you've just made a really cool-looking but totally useless piece of plastic.
To figure this out, let's think about it a different way. It's not about finding the one best material that works for everything. It's more like opening up a toolbox. You've got all these different materials, and each one is a tool for a very specific job.
And this is why that choice is so important. The polymer you pick, it dictates literally everything about the final object. Is it going to be strong enough to actually work as a replacement part? Is it flexible enough that it can bend without just snapping in half? Can it survive being left in a hot car all day? The material defines how your print will actually perform out in the real world.
So where do we even begin with this toolbox? Well, if you're using one of the super common printers, the kind that melts filament, that's called fused deposition modeling, or FDM, your journey pretty much always starts with two main materials. Just think of them as the hammers and screwdrivers of your toolbox. They're the workhorses.
And here they are. PLA versus ABS. This is the classic showdown, It's the first big decision every single person who gets into 3D printing has to make. And it boils down to a really basic trade-off. Do you want something that's super easy to print, or do you need something that's seriously tough and durable?
Let's really break this down. In one corner, you've got PLA. It's made from stuff like cornstarch, so it's a little more eco-friendly. And pretty much everyone loves it because it's so forgiving to print with. But, and it's a big but, it's kind of brittle and it really can't take the heat. In the other corner, there's ABS. This stuff is tough. It's got high impact resistance. It's what Lego bricks and car parts are made of. The catch, it is famously difficult to print with. It loves to warp and shrink, so you really need a heated setup to get it to behave.
And this really is the heart of the matter. You don't have to take my word for it. Research confirms what every maker already knows from experience. PLA is just one of the easiest materials out there to print with. A totally different world from the headaches you can get with ABS. When you're just starting out, that ease of use is a game changer.
But what if you don't want to make that choice between easy and strong? What if you want both? Well, material science didn't stop there. Let's look at some of the versatile upgrades that try to give us the best of both worlds.
This exact problem is what drove the next big wave of innovation in materials. People were asking, what if I can have it all? The dead simple printing of PLA, but with a part that won't snap when I look at it funny. The toughness of ABS, but without all the frustration of a warped print. Was there an answer?
Oh yes, there was. And its name is PETG. So you take the easy printing, low warping magic of PLA, you combine it with the durability and impact resistance of ABS, and boom, you get PETG. It's a special polymer that was literally engineered to hit that sweet spot right in the middle.
So why is PETG so popular now? Well, it's just incredibly practical. It's recyclable, it stands up to chemicals, and, this is a huge plus, it doesn't stink up the room while you're printing. It's even food safe, just like its cousin PET that's used for water bottles. But it does have an Achilles heel. It scratches easily, and it's what we call hygroscopic. That means it literally sucks moisture out of the air. You absolutely have to store it somewhere dry if you want to get good prints.
Okay, so we've covered the beginner stuff and the all-rounders. Now it's time to level up. What if you're not just printing a model? What if you're printing a functional part for a drone or a machine or even your car? Now you need serious engineering-grade performance. And this is where things take a massive leap. Look at this. PLA has pretty low resistance to impacts. ABS is much, much tougher. That's why we use it for things like phone cases. But then you get to polycarbonate, or PC. Look at that jump. It's not just a little step up, we are in a completely different league of toughness now.
And that's not just a number on a chart. To give you some real-world perspective, polycarbonate is the same material used to make things like motorcycle helmets and even bulletproof windows. It is unbelievably strong and heat-resistant. Of course, there's always a trade-off. It can be pretty tricky to print with, and it's a bit sensitive to UV light.
But PC isn't your only choice for engineering-grade parts. Let me introduce you to another powerhouse, nylon. If polycarbonate is all about pure rigid strength, then nylon is all about durable toughness and having a low-friction surface. It's incredibly resistant to wear and impacts, which makes it absolutely perfect for things that slide or move, like custom gears or hinges. But be warned, if you thought PETG was thirsty, nylon is even worse. Keeping it bone dry is absolutely critical to printing successfully.
But the story doesn't stop there. We are now heading into what I think is the most exciting area of all this, creating super materials by making these advanced blends and composites.
So what even is a composite filament? It's pretty simple, actually. It's a hybrid. You start with a base plastic, like our old friend PLA, and then you mix in some other substance to give it new powers. For instance, you can mix in fine wood powder, and you end up with a filament that prints an object that looks, feels, and can even be sanded just like real wood.
And the possibilities here are just wild. For pure lightweight strength, you can add bits of carbon fiber into something like nylon to make parts that are crazy stiff. For cool looks, you can mix in bronze or other metal powders to get a real metallic finish. There are even super specialized materials like alumamide, which is a mix of aluminum and plastic. And for pure utility, you have soluble filaments like PVA. You use them to print support structures that just dissolve away in water, leaving a perfect, clean model behind. It's incredible.
Okay, I know that was a ton of information. So let's boil it all down into a super simple cheat sheet. This will help you grab the right tool from that material toolbox for whatever job you've got next.
So here it is, your new toolbox. Next time you start a print, just ask yourself, do I need something fast, easy, and good for a quick prototype? That's PLA. Do I need something tough that can handle some heat? That's a job for ABS. Do I want a balance of both strong and simple? PETG is your friend. Do I need something that's practically shatterproof? Go for polycarbonate. Am I printing gears or parts that need to slide? That is nylon's specialty. And for the ultimate in strength without the weight, it's got to be a carbon fiber composite.
And you should know, this isn't just a niche hobby anymore. The market for just these composite printing materials is projected to be worth over $1.7 billion in the coming decade. This tech and these materials are fundamentally changing how we make things.
And that leads to one final kind of mind-blowing thought. Researchers have just recently figured out how to 3D print with a diamond composite. So I'll just leave you with this question. If we can already print with one of the hardest materials on Earth, what incredible new material is just waiting around the corner, and maybe even waiting for you to be the one to print with it?